Okay, baking soda and vinegar. You guys just saw it, right? So, what's the chemical formula for baking soda? So, baking soda is going to be sodium bicarbonate. So, what's the formula for that? Really? SO for sodium? Please. If you're watching this video, I'm so sorry that you just heard that. Na. And what's bicarbonate? H. Bicarbonate. Remember, carbonate's CO3 with a 2 minus. Bicarbonate is HCO3 with a 1 minus. All right, who remembers what vinegar is?
I don't.
Yeah. So vinegar is acetic acid.
It's H.
8. So
Is it H?
what's acetate? Oh, we need a naming quiz coming up real soon. C2H3O2. Oh, yeah. Yep. All right, take a second. Write it out. Write out the products. So those of you watching at home, I'm encouraging you to take a minute to write this out as well. What type of reaction is this? Double replacement, good. All right, so I see we've got sodium acetate. So for the two H's, we just combine them, right? So we get carbonic acid. Here's the thing with carbonic acid. Carbonic acid itself is actually not stable. So when you see this as a product, this is going to break down into water and carbon dioxide, which is why when you add baking soda to vinegar, it bubbles. Because it is a double replacement, but you're producing that carbon dioxide with it, which is the gas that's coming off of it. So that's why I'm going to take this guy out and move that up. Make sense? So from kind of here on out, if you see carbonic acid as a product, you got to flip it over to CO2 and H2O. All right, so here's my question for you. If, I got just a touch bigger for you guys. If 5 grams of acetic acid react with baking soda in a 500 ml container at 27, how to get that, there you go, degrees Celsius, what pressure is added to the container? So 5 grams of acetic acid react with baking soda in a 500 ml container. What pressure is added to the container? Okay, so let's think this through. The pressure is going to come from what? But plug what, right? You can only use Pivner for gases. So what compound is our gas?
H, H, HC2.
Vinegar? Vinegar is not a gas.
It was
What did we just talk about? What gas is produced in this reaction?
H2O.
Just CO2, right? When we just mix baking soda and vinegar, we're doing this at room temperature. Water's not going into gas phase, right? But we know carbon dioxide is a gas. So we know this guy is creating the pressure, right? So let's map this out. We're given grams of acetic acid. If we have grams of acetic acid, what can we use that to solve? We can use that to find moles. If we have moles of acetic acid, what can we use that to solve? What can we use that to find? Good, so we can convert moles of acetic acid to moles of CO2. And for CO2, we have moles. Do we have volume? Do we have temperature? Can we Pivner to find pressure? Yeah. All right, this is being frozen for anyone in person. Those of you guys online, I'm encouraging you to pause it or don't look at the screen while I write this out.
For Pivner, do we have to put vinegar in bowls?
Well, you can't put Pivner in vinegar. I'm sorry,
Vinegar.
you can't put vinegar in Pivner because vinegar is not a gas.
Oh, so we have to put vinegar in bowls.
Exactly. Yep, you got to do moles of vinegar to moles of CO2.
I feel like I'm a little stuck now.
Did you convert grams of acetic acid to moles of acetic acid?
No.
I mean, so we mapped out everything we had to do, right?
Yeah. Oh, so vinegar is.
Vinegar is acetic acid, yes.
feel like I'm close.
Oh no, I'm really close. I don't know how, but I did.
Well, here's the moles of CO2.
Oh my god, I was right.
Hold on, I don't want to look at.
No problem. That's just the moles of CO2 part.
I thought I was like I should have more moles.
No, 5 grams isn't necessarily a ton. I do want to highlight, even though it's 1-to-1, it is incredibly important that you show this stuff because if you're using Pivnert, you have to show that you're using moles of a gas, not just moles of the initial aqueous reactant.
Is it 3.66 moles? Is my setup right? Did I get a mass wrong?
You don't need to go to mass. Why are you going to grams? You don't need grams of CO2, you need moles of CO2.
Yes.
That's grams. That's giving you grams of CO2. If you're multiplying by 44 after this step here, that's grams. That's why watch your units. This is moles. That's what we're trying to stop at. So stop, right? You don't have to always go all the way to grams. That's why watching those units cancel and paying attention to what you need is great. You don't always need to go all the way to grams. 0.0821. Thank you.
So that's 300 gallons.
All right, you guys do the Pivnert part? Should be getting 4.1.
In my thing, but I didn't get that.
You converted volume to liters, 0.5, and temperature to Kelvin, 300? Okay. What'd you do? 500?
I think it's 500.
500, because it's 500 milliliters,
Okay.
but it's got to be liters, right? Because remember, 0.021 is atmosphere liter per mole Kelvin.
What is the point? Oh, that's Avogadro.
No, it's not Avogadro's number. It's the ideal gas law constant. Yeah. Avogadro's number is 6.02 times 10 to the 23rd. Oh, his law, that was the fact that if you add more gas, the volume goes up. I'm never going to be asking you to correlate names. It's one thing to do it for practice. I will never quiz you on, hey, what's the name? Well, that's why knowing the names of these laws isn't important. Just knowing what the laws are is the most important part. And for that, if you remember Pivnert, right, and you solve for R, so you have PV over NT, that is every relationship you need. P times V, P over T, V over T. No, black is not going to work. PV over T, right? All of those relationships are right there in Pivnert. So if you know Pivnert, you know everything.
How do I enter that in my calculator?
Multiply all of that and then divide by 0.5. Just come back very, very quickly. I mean, we're going to start a new problem. So if you want to go. Just come back very quickly. All right. Here is the next problem.
So first we need to create a gas, right?
Well, first you got to finish the equation.
Yeah. Is it KCl plus I?
No.
Oh yeah.
Right, ion's diatomic.
Yeah.
All right, balance it. Okay, now what kind of problem is this?
It's single replacement.
It's single replacement. What kind of, but like mathematically speaking, what kind of problem is it?
Oh, like what type of gas equation do I use?
Are you given information about both reactants?
No.
Yes.
Oh. Yeah.
You have grams of Ki.
Yeah.
And you have pressure, temperature, volume that relates to chlorine. So what kind of problem is this? Limiting reagent. Oh, it does. Absolutely does.
Like 11, 10. I'm gonna get a shirt that says I love 10. I'll wear just
All right, limiting reagent, right? Make sure you know which one's being used up. Again, this is being frozen for people in person. Those of you guys online, I encourage you probably to pause, come back to it. Well, the question's asking for how many grams of solid iodine are formed. So, I mean, you could pick the other one, but then it's just going to be more for you.
I'm close.
Take it one step at a time. Right? Look at Ki. Use all the Ki to figure out how many moles of iodine you would need. Use all of the chlorine to figure out how many moles of iodine will be produced. All right, whichever one's smaller is coming from the limiting reagent. You found the limiting reagent? Okay, then use that to figure out grams of iodine.
I feel like I'm no longer close.
It'll be the exact same number if I go from the limiting. With the limiting reagent, I don't start with the number, I start with just the mass, right?
Well, what'd you find as your limiting reagent?
Ki.
No. So take a look. Okay. So I took my 5 grams of potassium iodide, divided by 166 to give me my moles of Ki, divided by 2 to get moles of iodine. Okay. That gives me 0.0151 moles of iodine.
Oh, that's easy.
You can too. And if you do that, you would end up with you would end up with 3.82 grams roughly.
So how did that affect the Pivner problem if we didn't use moles?
So this is from the one reactant. Then you have to do it again basing it off chlorine. So you use Pivner to figure out how many moles of chlorine you have. Because you have a pressure of chlorine, you have a volume of chlorine, you have a temperature of chlorine. That will tell you how many moles of chlorine you have. So once you have your moles of chlorine, you can convert to moles of iodine, which if you just compare it by moles, you'll see that's fewer number. And then convert to grams, and you'll see that that's comparatively fewer grams of iodine.
Oh, no.
All right, giving everyone a minute to write everything down here. So here's the thing I want you guys to think about with Stoic. Right, the entire point of Stoic is to get from moles of A to moles of B, right? We've seen problems where we go from grams to moles and then back out to grams. We've seen molecules converting to moles and back out to molecules, right? Or some combination thereof. Now we just have another way to find moles, right? You can use Pivner to find your moles of A, or you can use it on the back end to solve, once you have moles, to solve for pressure, volume, or temperature. Right? It's just another way to find moles. All Stoic is the heart of Stoic is converting moles of A to moles of B. And then it's just, what are you doing to get moles? What are you doing with those moles once you have them on the back end?
I'm gonna draw it.
All right, I do have a practice sheet for you guys. Those of you who are online, I will post the sheet online as well. It's only 4 problems. The problems are more straightforward. They are pretty simple, just to get you guys practicing with the basics on this, okay? All right, I'm going to stop sharing. If you're watching the video and you have questions, please email me or comment on the post, and we'll go from there.